Let's do practice problem 16 on page 166. I'll read the problem. It says, racing on a flat track, a car going 32 meters per second rounds a curve 56 meters in radius. A, what is the car's centripetal acceleration? And B, what minimum coefficient of static friction between the tires and the road would be needed for the car to round the curve without slipping? Okay, so let's do part A, the centripetal acceleration. Well, the equation for it is centripetal acceleration is your speed squared divided by your radius. So this is pretty easy. We're given the speed and the radius. So this is 32 meters per second. We're going to square that. The radius is 56 meters. And so I get my quantum mechanical calculator out. 32 squared equals divided by 56, and I get 18.29, or actually I round it off. I'll call it 18.3. And look at the units here. The units are meters squared per second squared, because you're squaring that, and then divided by meters. So the meters cancels the meters here. You get meters per second squared. Yeah, that's what you should get. So that's my centripetal acceleration. And remember, this car is moving constant speed, and yet it is accelerating at that's a lot of acceleration, actually. Is that right? Did you guys get that?
Yeah.
Okay. So that's like, that's crazy. That's like 2 G's. I don't think this is a very realistic problem. Let's try B, because we want the coefficient of static friction. Well, the force of friction is equal to mu times the normal force. So mu is equal to the force of friction divided by the normal force. Well, let's draw a free body diagram. Here's the car on the road, and it's kind of zipping around this circle like this, so we're looking at it kind of edge on, and we've got gravity, mg. Now they didn't give us the mass, but we've dealt with that before, right? If I don't give you the mass, just stick with it. And then we've got normal force like this, and then I've got this force of friction between the tires of the road. And that is the agent. Friction is the agent that makes this car move in a circle. There is no applied force on this car. These are the only forces acting on this car, or this truck, or whatever. It's going around in this circle. So, let's make this the positive x direction, and this the positive y direction. Everything lines up with that. If I sum the forces in the x direction, that'll equal ma in the x direction. Why did I make positive x this way? Well, because that's the direction of my net force. Just makes it easier. So I've got this force of friction. It's the only force in the x direction. So therefore, it is the net force in the x direction, and it's causing my acceleration. If I sum the forces in the y direction, that'll equal ma in the y direction. Look in the y direction. I've got the normal force minus mg equals, and there is no acceleration in the y direction. The car is not flying into the air or sinking into the ground. So in the vertical direction, the car is not accelerating. Now this tells me that the normal force is equal to mg. So I got an expression for friction force, for normal force. So now I can solve for mu. The force of friction is ma. The normal force is mg. So the mass cancels. I've got an acceleration of 18.3 meters per second squared. I've got g is equal to 9.8 meters per second squared. And what do I get? I get 1.86. That's crazy. I don't know any track. Maybe there is a track. I don't know. I don't know if there's a track like that means that your friction force is 1.87. We'll call it 1.87 times your normal force. I think that's crazy. Let's look this up in the back of the book. What is it in the back? Six, 7. What problem is this? Problem 16. Yeah, 1.8. I don't know. That's very grippy.
Yeah.
Very, very grippy.
Tires.
But that is how you do that.
You got good tires, Mr. Lake.
Hey, everybody. That is all. 1, 2, 3.
That is all.